Alright, in this problem we are going to do an integration by substitution for this integral. Alright, we're going to do it for cosine of x over sine squared x, right, with respect to x. And this is a definite integral, so we're going to do it from our lower limit of pi over 6 to our upper limit of pi over 4. Now, before I continue on with this problem, let me just recall to mind a couple of things here, right, regarding some trigonometry. Let's see. First of all, you should recall from a 45, 45, 90 triangle, right, that there's our picture right there. And if I wanted the sine of 45, that's opposite over, right, the sine of 45, that's opposite over adjacent, which, by the way, in radians, sine of 45 is pi over 4. Hey, that's just simply 1 over the square root of 2. Now, I know that I could probably rewrite this thing so that I don't have a square root in the denominator, but I'm going to leave it just like that. Also recall that in a 30, 60, 90 triangle, right, it is set up this way. Let's see if I can remember this here. Right, for a 30, 60, 90 triangle, if you wanted the sine of 30 degrees, which in radians is sine of pi over 6, hey, that's just opposite, which is 1, over hypotenuse, which is 2, so I have 1/2. Okay, so remember these two ratios. 1 over square root of 2 for sine of pi over 4, and 1/2 for the sine of 30 degrees, or pi over 6. Okay, so with that in mind, let's go ahead and use integration by substitution on this problem here. So I'm going to start off by saying, hey, let's let u, right, and it could be any variable, really. You could put it, let p, let m, any variable you want, maybe other than x. Let's let u equal just the sine of x, right, just sine x. Not sine squared x, but just sine x. Alright, and I'm going to rewrite this in just a second over here. Well, if u is equal to sine x, then what's the derivative of u with respect to x? Well, the derivative of sine, is cosine, right? And I'm going to do one more thing. Let's get this du right here by itself. So algebraically, I'm going to multiply both sides by dx. Alright? And if I multiply the left-hand side by dx, the dx's are gone. You see that there, right? These guys are out of here. So I've got du is equal to, on the right-hand side, cosine x dx. Okay, so this is what I'm going to use to substitute, and this is what I'm going to use. Right, I'm going to let u replace sine x, and du replace cosine x dx. And sure enough, look, we have both of those here. Do you see that I've got cosine x dx? So I'm going to replace that with a du. Okay? And you see, in place of sine x, I'm going to put in the letter u right there. But this is sine squared x, so this is really, let me rewrite this now, this is really pi over 6 to pi over 4. Right, this is really 1 over u squared du. And again, where'd the u squared come from? That was sine squared x, so instead of u, I'm writing it as u squared because it was squared. And instead of cosine x dx, I'm replacing it with just a du. Right? Okay, let's see. Now, I'm going to rewrite this. I don't really like it as 1 over u squared. I kind of prefer to see it this way. I prefer to see it as, maybe you prefer it this way as well. Let's bring this u squared into the numerator. So I'm going to write it as u to the negative 2 du. Hope you're okay with that. Alright, now we are ready to integrate. Give me the antiderivative of u to the negative 2. Well, that is the process of adding 1 to that exponent, which now is a negative 1, and that new exponent of negative 1 moves to the denominator as well, right? Okay, so we have u to the negative 1 over negative 1, and all of this is being evaluated between pi over 6 and pi over 4. And if you want, you can clean this up a little bit more as well. Let's see, u to the negative 1, that really just moves to the denominator. And I've got a negative out front, so I'll just write it this way, negative 1 over u. Right, so this u to the negative 1 moved down, became a positive u. And that negative 1 that's in the denominator, well, there's my negative sign right there out in front. Okay, this is what I'm going to evaluate between pi over 6 and pi over 4. But there's one more problem left with this, and that is I didn't want the original problem said I don't want the integral of this with respect to u. I wanted it with respect to x, right? So I need to change and back substitute in place of u what we originally substituted it for, which was sine x. So I'm going to write this now, and I'm running out of room here. Let me switch over. I'm going to write this now as negative 1 over sine x. There we go. I've got negative 1 over sine x and evaluated that between pi over 6 and pi over 4. Right, and that's why I showed you. Remember, you have to recall to mind these two things here. We're going to need to know what the sine of pi over 4 is and what the sine of pi over 6 is. Okay, here it is. The sine of pi over 6 is 1/2, and the sine of pi over 4 is 1 over radical 2. Now, why did I write and leave this one like this? Well, here's why. The first fundamental theorem of calculus says to, in place of x, substitute in a pi over 4, my upper limit. I can do that right there. Minus, right? It's always minus. The exact same template here of a negative 1 over sine x, but in place of x, I'm going to substitute in pi over 6. All right, pi over 6. There we go. Alright, let's see here now. What did we say a moment ago that the sine of pi over 4 was? Hey, that's just 1 over square root of 2, right? But since this sine of pi over 4 is in the denominator, it's almost as if I was saying negative 1 over the square root of 2. And we don't divide fractions, we flip and multiply them, right? So I'm going to take this denominator, I'm going to flip it. Right, I'm going to flip it, and this whole thing turns into a negative square root of 2. That's my first term. Okay, this whole thing turned into negative square root of 2. Okay, since sine of pi over 6, whoops, here it is, here's my template. Since sine of pi over 6 is equal to 1/2, and I have a negative 1 divided by 1/2. Again, this is one of those flip and multiply things. So this thing in front, inside this square bracket here, is really a negative 2. Right? So I just flipped that. But there was a minus sign in front of all this, right? In between these two square brackets. So that just changes, right? That just changes the sign of my second term, which now becomes a plus 2. And so I have negative square root of 2 plus 2. Or maybe it's easier to see, and I kind of like it, it's a little bit crisper to see. I'm going to put the constant out first here, this 2 rather, out front, and write it this way. 2 minus square root 2. I'll put that out front, put this in the back. So there is my final answer, 2 minus the square root of 2. We could do that out in our calculator if my math lab or your instructor wanted that worked out to maybe the nearest hundredth or thousandth, I'm not sure. But there is our simplified and exact answer. Hope that helps.